Hi, welcome to Mr. P Helps with Calculus. This is day 1.5 of Unit 1, and we're going to be exploring an introduction into limits, which is sort of a prerequisite skill that you should already have at this point from pre-calculus. So as x is getting closer and closer to some sort of number on a function from both the left and the right-hand sides, it should be approaching some sort of height. That is where it means limit. So a limit just means the highest point where it could be as it is approaching from both the left-hand and right-hand sides. So as x is approaching some sort of number, which happens to be c, of the function f of x, and it could be anything, then L would be your limit, which would be your answer to that function. So as the limit as x approaches 3 of the function 4x, we could find the answer. We could find L, which will be the limit at 3, meaning where does the graph approach at 3. Doesn't mean that's what it is at 3, but we'll get into that later. And I simply just take that value and I plug it into the function. So 4 times 3 happens to be 12. So you would say that the limit as x approaches 3 of 4x would be 12. All right, so we can also indicate that the end behavior, so we're going to talk about end behavior. That means the behavior of a function as it approaches the furthest it can be from the left or to the right. So the right end behavior would be what's happening to this graph. Now this graph happens to be a piecewise, and there's multiple parts to it, as you can clearly see. But the furthest you can get to the right would be this piece. And then as this piece gets closer and closer and closer to the right, what it's happening is that it's getting closer and closer to this horizontal asymptote. So it's getting closer and closer to 2. Now, will it ever reach a height of 2? No, it's actually never going to reach a height of 2. No matter how far to the right you go, it's just going to keep getting closer and closer. So essentially, the way of looking at this is you would need a more powerful microscope, and you would have to zoom in more and more the further you go to the right, but it's never going to actually reach this dotted line. You would just have to keep focusing and keep zooming in over and over and over and over again. Same thing's happening to the left as we have this horizontal asymptote. So this piece will never hit or cross that dotted line. It'll keep getting closer and closer and closer to the same effect as the one on the right-hand side, but this one's reaching a height of -3. Once again, so it's a limit is what it's approaching. It's not necessarily what it is at that point. And we'll get to that here in this example. So what we see is we have a hole right here that's been removed and moved to this height of f of a. So f of a just happens to be the height of this point. Now, we would still say the limit at a would be this height because both the left and the right-hand sides are approaching that height of the hole itself. F of a would be a completely different height, but that's not the limit. The limit is the behavior of the function that happens to be approaching at that x value. So in this case, once again, we have actually 2 types of discontinuity. We have jump discontinuity and we have removable. We have this point which has been pulled down here. Now, we could say that the left-hand side's approaching a height of about 3. The right-hand side's approaching the height of about 6, and I just made up these numbers. But the actual value happens to be a height of 0. Now, this does not have a limit because the left and the right-hand sides do not approach the same height. They have to be the same in order to be a limit. Now, down here, we have some infinity examples where either both of them are leading up towards infinity or down towards infinity. Now, that does have a limit. If both the left and the right-hand sides at 0, or in this case at c, which is what I've written, does have a limit of positive infinity because both the left and right-hand sides are both approaching infinity. Same thing with going down towards negative infinity. Well, yes, both the left and right-hand sides are both still approaching that height. Now, you can clearly see I have a lot of examples here, and through these notes that you're taking a look at, I'll go through a few pages, but as you just look through the notes on the one that I've posted on Canvas, you'll see that there's a lot more pages and a lot more examples in case you want to try some yourself. Now, the limit as x approaches negative infinity, that means left-hand end behavior. So that means we're approaching on the x-axis, we're going to the left infinitely. Well, that's approaching a height of -3. So remember, the limit is always going to be the height that it's approaching. So if you're approaching -4 from the left, now I didn't get to talk about that just yet, but sometimes we have next to the number that it's approaching, we have these little minus or plus signs. So left would be negative. Left is on the left side of it would be the negative, and on the right-hand side of it would be the plus. Now, if you don't see a left or a right hand or a little minus or a little plus in the superscript, then essentially you're just asking for the limit of that number itself. So these three questions are kind of tied together. -4 from the left, if I look at -4 from the left, it is approaching negative infinity. And then -4 from the right is also approaching a negative infinity, which means that therefore -4 does have a limit. These two have to be the same for this to be an answer. Now, as we look at the next question, it looks like we're looking at -2 now. -2, the left-hand side is approaching a height of -5. The right-hand side is approaching a height of 0. These two are not the same, so therefore it does not have a limit. It does not exist. Now, in calculus, we're going to write DNE just to save ourselves a little bit of time. That means does not exist. Now, 0, for example. 0, well, this time it looks like the two pieces do meet each other. So now, keep in mind that as x approaches 0 from the left, it's approaching a height of 3. Approaching from the right, it's a height of 3. Now, if I ask you what f of 0 is, f of 0 would be 4. F of 0 equals 4. But that actually doesn't matter when it comes to limits. So just because the left-hand side and the right-hand side, just because they don't meet what f of 0 actually is, it still has a limit. Because the left and right-hand sides meets the definition of a limit, they are both approaching the exact same height. So yes, the limit does exist, despite the fact that this point has been removed, which is something we're going to be talking about in a future video as well. So let's take a look at 1 now. 1, yes, the left-hand side is approaching a height of 0. The right-hand side is approaching a height of 0. In fact, even f of 1 is 0, but that's irrelevant. It had a limit anyway. But yes, that point happens to also be 0 as well. 5 from left and right. So if you look at 5 from the left, it's going down towards infinity. From the right, it's going up towards infinity. Those are not the same thing. So no, the limit does not exist. You cannot have one going up and one going down. So that would not exist. All right, so like I said, if you check through my notes on Canvas, you're going to see lots of examples like this where lots of more different types of graphs with piecewise graphs mostly. And you can kind of test yourself to see if you got the same answers as I did. Thanks again for watching. Have a wonderful day, and see you on the next video.